Hello everyone, welcome to the next tutorial. In this tutorial, we are going to find the equivalent capacitors, equivalent capacitance of the capacitor when they are connected in your series or you can say parallel, okay? So let's say in the first case, let's say two capacitors are connected in series, okay? Let's say this is capacitor C1 and this is C2 and they are connected across a voltage source, a DC voltage V, okay? Let's say the I is the current flowing from it, okay? And the charge stored, since they are connected in series, so they will store the same amount of charge, okay? So the charge that is stored by these two capacitors is your Q, okay? So we can say that according to KVL, okay? So according to, you can say KVL, Kirchhoff's voltage law, we can say that V will be equal to, so the voltage drop across capacitance C1, which is let's say V1 plus the voltage drop across this particular capacitor C2, which is your V2. So V is equal to V1 plus V2, okay? So we know that Q is equal to CV. It means that V will be equal to Q upon, so the total charge divided by the total, or you can say the equivalent capacitance C equivalent, okay? So which will be equal to V1, which is equal to Q over C1 plus Q upon C2. So if we evaluate it, we are getting 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2. So it means that C equivalent is equal to C1 C2 over C1 plus C2, okay? So it means that when n capacitors, so for n capacitors connected in series, so connected in series, we can say that the equivalent capacitance will be equal to 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2 plus so on 1 upon Cn, okay? So I hope it is clear how we are approaching to this particular expression, okay? Okay, so now let's find the equivalent capacitance of the capacitors when they are connected in your parallel, okay? Parallel. So let's say we have two capacitors C1 and C2, okay? And they are connected across a voltage source of voltage V, okay? Let's say this is the current I which is flowing. I1 is the current flowing from C1 capacitor and I2 is the current flowing from C2 capacitor. So it means that the charge that will be stored, since they are connected in parallel, so they will store different amount of charge, okay? So the charge stored in the capacitor C1 is your, let's say, Q1, okay? Similarly, the charge stored in the capacitor C2 is your Q2. So according to the law of conservation of charge, we can say that Q is equal to Q1 plus Q2, okay? So as we know that Q is equal to CV, it means that, so as we know clearly, so Q is equal to CV, so it means that C equivalent into V is equal to C1V plus C2V, because the voltage in case of parallel connection, remains the same. So on taking V common, we can say that C equivalent is equal to C1 plus C2. So for n capacitors connected in parallel, so the total capacitance or the equivalent capacitance will be equal to, so it will be equal to C equivalent is equal to C1 plus C2 plus so on plus Cn, okay? So I hope it is clear. So that's all for today, guys. I will see you in the next tutorial.